view, that is the sectional front view and top view of the first part, that is the fork, and we have completed the sectional front view and top view of the second part, that is the center block. Today we will be drawing the sectional front view and top view of the remaining parts, that is the vertical pin, part number 3. Then we will draw the front view and top view of part number 5, that is the collar. Similarly, we will draw the front view and top view of the shaft or side view of the shaft, that is the part number 7. So in the previous session we have drawn the sectional front view and top view of the part number 1, that is the fork, and in the second session we have drawn the sectional front view and top view of part number 2, that is the center block. Today we will draw the front view and top view of the vertical pin and the horizontal pin, as well as the front view and top view of the collar and the shaft. So let's begin with the diagram. So here I am writing pin. Now for drawing the pin, we will see the dimensions of the pin first. Now you can see here this vertical pin is inserted inside the fork as well as the cylinder of the center block. Now we have to identify the dimensions of this pin. Now first we will identify the height of the pin. In order to identify the height of the pin, we will see the dimensions from the front view as well as from the top view. Now the total height of the pin from this line, that is this point, to this point can be identified from the front view. Now we can see the total height from this point to the end will be equal to 30 of this upper part, 30 plus 106 plus 30 plus 13. So the total distance from this point to this point is equal to 30 plus 106 plus 30 plus 13, and the total distance will be equal to 166 plus 13 169 plus 10 179. So the total distance from this point to this point is equal to 179, and the remaining distance at the bottom from this point to last is equal to 7. So total distance will be equal to 179 plus 7, that will be equal to 186. So the total height of the pin from this point to this point will be equal to 186, that is addition of 30 plus 106 plus 30 plus 13 plus 7. So the total height is equal to 186. Now the height of this upper part as well as the diameter of this upper part can be found out from the top view. Now we can see the height of this upper part is equal to 13. From the top view, this is the top view of the horizontal pin. So it is having the top diameter or the head diameter as 60, whereas the height of this upper part is equal to 13. So we have found the dimensions of the vertical pin. The height of this upper head will be equal to 13 mm. The diameter will be equal to 60 mm from the top view, and the total length from this point to the end will be equal to sum of all these distances, that is equal to 186. So now we will draw the front view and top view of the pin. So first we will draw the head of the pin. So this is the head of the pin, which will be equal to of length 60 mm and height is equal to 13 mm. 60. So till now we have drawn the head of the pin. So this is the head of the pin. This is the head of the pin with dimensions height equal to 30 mm, 13 mm. From the question it was, we have found that height was equal to 13 mm, whereas the diameter of the top part is equal to 60 mm. This diameter is equal to 60 mm. So we have drawn the head of the pin. Now we will first draw the center line of the pin. So we will mark the center of the pin. So this is the center line. Center line will passing through the center of the head. So this is the center line of the pin. Now the diameter of the lower part, you can see from the figure, the diameter of this lower cylindrical part is equal to 30 mm. So this lower cylindrical part, which is of length 186 mm, will have diameter as 30 mm. So now we will mark the diameter, that is equal to 30 mm. For that we will take a distance of 15 mm towards right. So from this point you have to take a distance of 15 mm towards right and 15 mm towards left. So from this point we will take a distance of 15 mm towards right, and then we will mark the length is equal to 186. reference. So from the center we will take a distance 15 mm towards left, and then we will mark the height is equal to 186. So you can see we have drawn the front view of the pin, partial front view. This total height will be equal to 186. We will give the dimension here. You can see the dimension. The dimension is equal to 186. So the total height of the pin is equal to 186. Now from this point we will mark the distance 30, which is equal to diameter of the pin. So this distance from this point will be equal to 30 mm. So we will give the dimension here. So this line is of dimension 30 mm. Since the lower cylindrical part of the pin is of diameter 30 mm. Now we will complete the pin, front view of the pin. Again we have drawn a line of length 186 from bottom to the top. So finally we have completed the front view of the vertical pin, which will be same as that of the horizontal pin. The total length is equal to 186. The diameter of this lower cylindrical part is equal to 30 mm. The diameter of the top head is equal to 60 mm, whereas the height of the upper part is equal to 13 mm. Now we will draw the top view of this pin. Now since the pin is cylindrical in nature, the top view will consist of two circles. One circle will be visible circle of diameter 60 mm, whereas the second circle will be a hidden circle of diameter 30 mm. Now I am deleting this dimension. In order to draw the top view, first we will extend this center line. I am extending the center line. Now taking this any point at the center, we will draw a circle of diameter 60 mm. This diameter will be equal to 60 mm. Taking any point at the center, we will draw a circle of diameter 60 mm. So you can see this circle is a visible circle which will represent the top view of this upper part. This is a cylindrical part with diameter 60 mm. So this circle is of diameter 60 mm. We can give the dimension here. You can see. So this circle is of diameter 60 mm. Now we will draw the second circle which will be hidden from the top view. If you observe this pin, we cannot see this lower cylindrical part because it lies below the head. So this lower cylindrical part will not be visible from the top view. So for this we have to draw a dotted circle or hidden circle in the top view. So now we will draw a hidden circle in the top view with same center. We will draw a circle which will be of diameter 30 mm. This part is of diameter 30 mm. So this circle will be a hidden circle. You can see this is a hidden circle of diameter 30 mm. So now we will give the dimension here so you can understand. So this diameter is equal to 30 mm, whereas diameter of the outside part, this diameter, that is diameter of the outside circle, will be equal to 60 mm. We will give here dimensions 60. So finally we have completed the front view and the top view of the part, that is the pin. So this is the front view and this is the top view of the pin with this diameter as 30 mm and this outside diameter as 60 mm. So we have completed the third part, that is the pin. Now in the next step we will draw the sectional front view and top view of the next part, that is the this part number 5, that is the collar. So you can see this part number 5. As from the part list, part number 5 is the collar, is made up of mild steel and its quantity is 2. Before this, we have drawn the front view and top view of the part number 3, that was pin, which was in quantity 2 and made up of mild steel. Now we are drawing the front view and top view of the collar, which is again made up of mild steel and its quantity is 2. So for drawing the collar, we have to first identify the dimensions of the collar. So this part in which sections have been shown, you can see this lower part. inside which the pin is going, or inside which the pin is passing through, is of diameter 50 mm. You can see from the top view the diameter of this collar is equal to 50 mm. So this collar will be of diameter 50 mm. Now the height of the collar you can observe is equal to 13 mm, which is visible from the front view. So from the front view we have got the height which is equal to 13 mm, whereas the diameter of this collar is equal to 50 mm. Now the collar is having a cylindrical hole inside it which will be of diameter 30 mm, since the pin is passing through the collar. Also, at the center of the collar, there will be a taper, there will be a hole for inserting the taper pin, and this hole is of diameter 6 mm. So, for drawing this collar, we needed the height which was equal to 13 mm, the diameter was equal to 50 mm, and the hole inside, or the cylindrical hole inside the collar was of diameter 30 mm. Also, the hole provided inside the collar for inserting the taper pin is of diameter 6 mm. So we have obtained all the dimensions related to the collar. Now we will draw the collar. So for drawing the collar, first we will draw the collar which is of diameter 50 mm. The diameter of the collar is 50 mm. So first we will mark the length is equal to 50 mm diameter. You can see the dimension. The dimension will be equal to 50 mm. So the length of the collar is equal to 50 mm and the height was equal to 13 mm. So now we will draw a vertical line of length 13 mm. From this point we will draw a vertical line which will be of length 13 mm. So this line is equal to of length 13 mm. So we have drawn the two lines, one horizontal line representing the diameter of the collar which is equal to 50 mm and the height of the collar is equal to 13 mm. Now since this is a diameter, so we will insert the dia symbol here. So diameter 50 mm. Now we will complete the collar. Again we will take a distance of 50 mm and then we will complete the collar. So we have drawn the collar. Now we will draw the hole or cylindrical hole which is present inside the collar. Before that, we will draw the center line of the collar. So the center line will be passing through the midpoint of this line. You can see this is the midpoint. So now we are drawing the center line. So this is the center of the collar. Now we have to draw a cylindrical hole of diameter 30 mm. So we will take a distance of 15 mm from this point. From the midpoint, take a distance of 15 mm towards the right. And again, from the same midpoint, take a distance of 15 mm towards left. So this is a cylindrical hole which is present inside the collar and its diameter will be equal to 30 mm. We will give the dimension here. So you can see the diameter is equal to 30 mm. We will insert the symbol. So finally we have drawn the collar with outside diameter as 50 mm and the inside diameter of the cylindrical hole as 30 mm. Now we have to draw the hole inside the collar which will be used for inserting the taper pin. In the question we have seen that there is a hole present at the center of the collar for inserting the taper pin. What is the use of this taper pin? This taper pin which is inserted through this hole will lock the collar with the pin, so that during the motion or during when the power is transmitted from this shaft to the second shaft, this pin will not slide in or move in outward direction. So this taper pin is used to lock the collar with the vertical pin, and this taper pin will be inserted inside a hole which is of diameter 6 mm. So this hole is of diameter 6 mm. So now we have to draw this hole in the front view of the collar. So in order to draw the hole, first we will mark the center of the hole. Now the center of the hole will be at a distance of, the total distance is equal to 13 mm. So we have to mark the center. So the center will be at a distance of 6.5 mm from this bottom point or from this point. So now we will take a distance of 6.5 mm from the bottom point and we will mark the center. So you can see this center line which is at a distance of 6.5 mm from the bottom line. So now we will give a dimension. The distance from this point will be equal to 6.5 mm. So the distance from this base to this center will be equal to 6.5 mm. Now taking this point as the center, we will draw the hole for inserting the taper pin. Now the hole was having the diameter as 6 mm. So with this center we will draw a circle of diameter 6 mm. So this is the front view of the collar. Now this part is a cylindrical hole and this is also a hole. So these are basically a hollow part, whereas this part on the left hand side and this part on the right hand side is a solid part. So we have to show section lines inside the solid part. Now we will show hatching lines or the section line inside the solid parts. So here, we have finally completed the sectional front view of the collar with outside diameter 50, inside diameter 30, height as 13 mm, and the center of this hole is at a distance of 6.5 mm from the base. Now we will mark the dimension of this hole also. Now this hole was of diameter 13 mm. So now we will give the diameter. So the diameter of this part. So you can see here the diameter of this hole is equal to 6 mm. So finally we have completed the sectional front view of the collar. Now we will draw the top view of the collar. Now since this is a cylindrical part, so the top view will consist of circles. Now the outside circle will be of diameter 50 mm and the inside circle will be of diameter 30 mm. And if we observe this collar from the top view, both the outer circle and the inner circle will be visible. So now we will draw the top view. Before that we will extend this center line. Now we will draw a horizontal center line. Anywhere here, we will draw a horizontal center line. Now taking this point as the center, we will draw two circles, one of diameter 50 and the second will be of diameter 30 mm. So from this point, we will draw a circle of diameter 50 mm and the second circle will be of diameter 30 mm. So this circle is of diameter 50 mm and the inside circle will be of diameter 30 mm. Now this hole which is present at the center of the collar has to be drawn in the top view. Now since this is a hollow part, the hole will not be present here. The hole will be present in the solid part only. So we have to show this hole on the upper half and the lower half. So now we will show the hole. Now this hole when observed from the top view will not be visible. So it will be shown with the help of the dotted lines in the top view. So now we will draw the hole, top view of the hole. So from this center, you have to take a distance of 6 mm. The total diameter of the part is of the hole of this hole is equal to 6 mm. So from the center, we will take a distance of 3 mm towards left. From the center, we will take a distance of 3 mm towards left, and then we will draw the hidden line. Similarly, from this center, again we will take a distance of 3 mm towards the right, and then we will draw again the hidden line to represent the top view of the hole. So you can see here, now we have drawn. So this is the top view of the hole which is of diameter 6 mm. Now this hole is present only inside the solid part. So this part is the solid part whereas this part is a hollow part. So we have to delete these lines from the hollow part. Now we will delete the extra lines from the hollow part. So finally we have completed the top view of the collar. So this is the top view of the collar with inside diameter 30, outside diameter 50, and this taper pin hole which is of diameter 6 mm as observed from the front view. So finally we have completed the sectional front view and top view of the collar also. So we have completed the sectional front view and top view of the collar. Now in the next step we will draw the front view and the side view of the shaft. Now you can see here in the question, the shaft which is inserted inside this hole will be of diameter 50 mm. The diameter of this shaft is given as 50 mm, whereas the length of the shaft will be equal to 86, since this portion from here to here is equal to 86, whereas the dimension of the part which is outside the hole is not given. So we will assume some length of the suitable length of the shaft. So we can here assume this length of which is lying outside of the hole equal to 20 mm. So the total length of the shaft will be equal to 86 plus 20. You can also assume 30 mm if you want, but here we are assuming the length of the shaft is outside the hole as equal to 20 mm. So the total length of the hole of the shaft will be equal to 20 plus 86, that will be equal to 106. So the length of the shaft is equal to 106 mm, whereas the diameter of the shaft is equal to 50 mm. Now we will draw the front view and the side view of the shaft. So here we will draw the front view and top view of the shaft. For drawing the shaft, first we have to draw a line of length 50 mm, since diameter is equal to 50 mm. So I am drawing a line of length 50 mm, and the total length of the shaft we have assumed as 86 plus 20, so it will be equal to 106 mm. And now again we will draw a line of 50 mm, and finally we will join the upper 2 points. For drawing the shaft, now we will mark the center line. So we will mark the center of the shaft. So this is the center of the shaft. Now here we have to show a break in the shaft, since the total length of the shaft is not given. You can see here that the shaft may continue here in the right direction also. Here a break has been given in the shaft, so the exact length of the shaft is not shown. So you have to show a break, since the exact length of the shaft is not shown here. Now we will show the break in the shaft. Here we will show the break. Now we are going to show the break inside the shaft. So now we will again here show the break inside the shaft. Okay, so we have shown this break which is present in order to denote the appropriate length of the shaft. Now we will delete this line. So we have drawn the front view of the shaft. Now since we have shown here break, means this part is a solid part. So we have to show section lines inside the solid part or inside the break. So here we are showing the section line inside the break. We have shown section lines. So this is the front view of the shaft. Now we have taken the length as 106. So I am giving the dimension here as 106. Length is equal to 106, whereas the diameter of this part is equal to 50 mm. So we will give here diameter also. So the diameter of this part is equal to 50 mm. 50. So we have drawn the front view of the shaft, which is of diameter 50 mm and length 106 mm. Now we will draw the side view of the shaft. For drawing the shaft, side view of the shaft, first we will draw the vertical center line from this point, and then we will extend the center line below. So we have drawn the center line. We will extend the center line also towards the right hand side. Now it is obvious that if we observe this shaft from this side, we can observe a circle which will be of diameter 50 mm, and this circle will be visible. So the side view will be nothing but a circle which will be of diameter 50 mm. So now we will draw here a circle of diameter 50 mm. So with this center, we will draw a circle which will be of diameter 50 mm. Now since a break is shown here, this is a break shown here, there is a solid part, we have to show hatching lines inside this circle also. Before that, here we have to show the key slot also. Key slot. You can see here from the question that this shaft is locked with the vertical fork by using this key. We have locked the shaft with the vertical fork by using a key. So a slot has to be drawn inside the shaft because the total height of the key was 10 mm and the 5 mm of the key height was inside the fork, whereas 5 mm will go inside the shaft. So in order to insert the key inside the shaft, a hole or a slot has to be created inside the shaft, and this slot will be of height equal to half of 10, that is equal to 5 mm. So now we will show the slot inside the shaft. We have to show a slot inside the shaft. Now we will take a distance of 5 mm in downward direction. So you can see here, this is the slot which is provided for inserting the key inside the shaft, so that the shaft gets locked with the both horizontal fork as well as the vertical fork. Now this slot is of height 5 mm, so we will give you a dimension. The total height will be equal to 5 mm. You can see the height of this slot will be equal to 5 mm. Now in the side view, we have to show hatching line inside the circle also, since it is a solid part and it has a break has been shown here. So now we will show the hatching lines inside this part also. From the side view, if we observe this slot, it will be not visible. It will be not visible from the side view. So we have not shown this slot here. So finally, we have completed the sectional front view and the side view of the shaft with the given dimension. That is the length which is assumed as 106 mm and the diameter as 50 mm. And the slot inside the shaft, key slot inside the shaft is of height 5 mm. So you can observe here we have drawn the sectional front view and the top view of the different parts. That is, the first was the fork, sectional front view and top view of the fork. The second part, that is the center block, sectional front view, and here is the top view. The third part is the pin, cylindrical pin, sectional front view, and the top view. The fourth part was the collar. Again, we have shown you the sectional front view and top view. And the last part we have drawn is the shaft, that is the sectional front view and the side view. Now students, note here that in case of fork as well as center block as well as collar, we have shown hatching lines inside those parts after taking the section. But in the pin and the shaft, we have not shown any hatching lines, though these are solid parts. And we have cut the pin also. This is because for pins, shafts, keys, hatching lines are always shown across the cross section. That is, if we cut this pin across the cross section, that is, if we cut this pin across this dimension, That is, if I draw a section line as this, if I cut this pin from here, then we have to show the section lines in the top view. But if you cut the pin along its height or along its length, we never show the section lines in it. So for shafts, for keys, we never show section lines when the shaft and the key is cut along its length. So you can see here, this was the length of the shaft. We have cut the shaft also from the center. Since we have cut the entire assembly from the center, so the shaft is also being cut from the center, but we have not shown the section line inside this part because it has been cut along its length. But in the side view, you can see that we have shown section lines because we always show the section lines for the shaft, for the pin or the keys in their side views or across their cross section. So we have shown the hatching lines in the cross section of the shaft. So finally we have completed the detailed drawing of the universal coupling with 5 parts, that is the fork, center block, pin, collar and the shaft.